Who would have thought that in 2020, someone would have invented a time machine? No, it's not the time machine that's going to fast forward you out of 2020 into simpler times. This time machine is going to save you time, and it's going to be small enough to fit in your tool belt. We are Inchworm, and we're rethinking precision tooling. Our team consists of Marissa Brazawi, a project engineer at MD Helicopters, Enoch Darko, a systems engineering graduate student from Ghana, myself, Derek DiNardo, a captain in the United States Air Force, and Billy Milanese, a systems engineer at Lockheed Martin. Marissa's going to tell us more about why we're here.
Thank you, Derek. So I work in the aerospace industry, where each of our aircraft are filled with complex line replaceable units, or LRUs. These LRUs are connected through a system of wire harnesses that route from tip to tail and back again. If you were to open up an avionics bay, you would find an absolute mess of wiring. Aircraft OEMs and repair stations often need to measure harnesses and double check lengths, but this is easier than it sounds. First of all, uninstalling a wire harness is tedious and non-value added, which means that it's a total waste of time. Second, deconstruction to remove a wire harness may lead to preventable damage of components. Last, there's no accurate way to measure a wire harness that is terminated and installed. So looking at some of the existing methods, you can use the machine of the example that's shown here, but this has to be mounted to a shelf, and it's really only good for harnesses that aren't already terminated, which renders it completely useless for basically any harness that has already been pre-built. You could take a harness and lay it out on a 1-to-1 scale, but this takes a lot of time and it requires a significant amount of space. You could run cloth tape through an aircraft in order to double check measurements or come up with measurements. And it's an option, but cloth doesn't behave the same way that wire harnesses do, which means that you're not getting an accurate representation of what the wire harness bend radius will look like. You could also use a floor tiles method, but this requires a lot of space as well. And lastly, you could use just a simple hand over hand method, which is a brute force way, and it's not very accurate. So Billy, why don't you tell them what you found?
Our solution is a specialized tool designed for technicians, electricians, and home improvement experts to measure the length of installed wires and cables that is simple, portable, and accurate. Our tool is accurate up to a 1/16 of an inch over a 100-foot length of cable. It's portable, so it's designed to fit in your tool belt and go where you go. And it's simple. If you can reach it, Inchworm can measure it. Our product's rugged body allows the Inchworm to be used in a variety of harsh environments and on the job site. The ratcheting locking mechanism allows for adjustable diameter of cables up to 3 inches. The spring-loaded linear ball bearings allow the Inchworm to navigate down the length of cable with ease. And the herringbone roller bearing counters allow for accurate measurements, which are easily read on the digital display. Enoch will describe our next slide.
We discovered from our market research that there are more than 1.1 million technicians in the defense industry, aviation industry, electricians, and then home improvement. Out of these 1.1 million technicians, they spend $7,000 to $27,000 on tools per technician over their career. From the spendings on measuring with a cable tool, our team was able to come up with around $75 on the price of our tool. And from this $75, and then the over 1 million technicians, we came out with a total available market, which represents the demand of the market for our tool to be $83 million. So this $83 million represents the market demand for our products. And in our product is going to be distributed. We will have distributors for our product. And in order to do that, we will spend 20% of the amount of each tool for the product. And for that reason, 20% of the $75 will give us $15, which means that to acquire a new customer, we will spend around $15 to acquire a new customer. And we are estimating our tool to last for at least 5 years. And then the lifespan of each customer to be around 10 years, which will give us a lifetime value to be around $300. Derek will continue with the market segment.
In order to make this happen, we're going to implement a 3-phase go-to-market strategy. Phase 1 is going to be direct to customer sales. We're going to do that via an Amazon store on the internet to get directly to our customers. Phase 2 is going to be business to business relationships. We're going to use the relationships we have and the companies we work at to garner a reputation to make us more attractive to get to phase 3, where we're going to market to distributors and they're going to distribute our product around the globe. We've come up with 3 different milestones in order to make that happen. And by month 6, we're going to have a final product. It's going to be an engineering design model that does exactly what we say it does. By month 12, it's going to be certified for use by ASME. And by month 18, we're going to have the relationships established with our distributors, Home Depot, Lowe's, Grainger, MSC, and Powell Electronics Group. In order to make this happen, we're asking for $750,000. We're going to use that on overhead for facilities, salaries, and utilities of the people making our tool, equipment, material, and consumables in order to make the tool, certifications for ASME and the legalities associated with that, and the costs associated with garnering our partner relationships with our distributors. Thank you for considering Inchworm, where we're rethinking precision tooling.